The last time it snowed in Boston in late May, it was 1977. Tonight, the model guidance just put the snow line back over the city. And the same storm is producing 65-mile-per-hour gusts on Cape Cod, record near overnight cold in New York, and damaging winds along the entire New England coast on the Saturday of Memorial Day weekend. There is one specific reason this is all happening at the same time, and most of the country has no idea it is unfolding. Stay with me. Once you see the pattern, you will not unsee it. A high wind warning is in effect for Cape Cod and Nantucket from 8 in the morning to 8 in the evening today, Saturday, May 30th, 2026. The National Weather Service Forecast Office in Boston issued the warning yesterday afternoon, and it calls for sustained north winds of 25 to 35 miles per hour, with gusts to 65 miles per hour across Barnstable and Nantucket counties. The forecast language is direct. Damaging winds will blow down trees and power lines. Power outages are possible. Travel will be difficult, especially for high-profile vehicles. That is not boilerplate. The Boston Forecast Office has issued fewer than 10 high wind warnings during the month of May for the Cape Cod and Nantucket zones over the past 20 years. Today's warning is one of those rare issuances, and it is landing on the busiest summer travel weekend of the year. The wind is only part of what makes this storm worth your time. The wind is the headline, but the storm that is producing it is bringing a second element that has not been seen in the Northeast for decades. Late May snow is in the forecast for parts of New England, and the snow line on the model guidance overnight reached as far south as Boston. The forecast does not call for measurable accumulation in the city itself, but the proximity of the snow line to a major urban center in late May is a rare event the meteorology community is going to note for years. The storm responsible for the warning is a closed low-pressure system that has been dropping out of Canada through the overnight hours. Its central pressure is collapsing toward 999 millibars. By Saturday afternoon, when the storm is at peak intensity over the Gulf of Maine, the model guidance is showing pressure rises of 5 to 7 millibars per 3 hours as the low deepens and pulls off the coast. In the technical language of cyclone intensification, that rate of deepening is in the range that meteorologists call bomb adjacent, referring to the formal definition of a meteorological bomb, a low that deepens by 24 millibars in 24 hours. The storm is not in the same magnitude class as the famous winter nor'easters that this region experiences a few times per cold season. It is, however, in the same general structural class. The closed low has the architecture of an off-season nor'easter dropped onto the calendar of May 30th. Forecasters in the Boston office describe the storm in their morning discussion as anomalously strong and quick-hitting, embedded inside what they called a highly amplified pattern. There is a specific reason the gust forecast on Cape Cod is 65 miles per hour, rather than the more typical 40 to 50 miles per hour you might expect from a closed low of this central pressure. The reason has to do with where the strongest winds aloft are sitting and how easily they can reach the surface. In a typical coastal storm, the strongest winds in the lower atmosphere are sitting up at 5,000 to 10,000 feet of altitude. The boundary layer down at the surface, slowed by friction with trees and buildings and water, does not normally tap into those high altitude winds. You experience a filtered version. Most of the wind stays aloft. In this storm, that geometry is different. The strongest winds aloft are sitting at 2,500 to 4,500 feet, lower than commercial flight paths, lower than most weather conditions ever bring the strongest wind layer. And the temperature structure of the atmosphere on Saturday afternoon is producing what meteorologists call vigorous mixing, where parcels of air at the surface get lifted easily and parcels of air aloft get pulled down easily. The result is that the wind speeds aloft are being handed almost directly to the surface. The high wind warning forecast of 65-mile-per-hour gusts on the Cape is the operational expression of that geometry. For the marine community, the situation is just as serious. 5 separate storm warnings have been issued for the coastal waters running from Cape Elizabeth, Maine, south to Montauk, New York. The warnings call for north winds of 25 to 40 knots with gusts to 55 knots and seas of 6 to 13 feet across the open coastal waters from Provincetown to Nantucket. The forecast language in those warnings reads, and I am quoting directly here, "Storm force winds and hazardous seas will capsize or damage vessels and reduce visibility." The wind is only one face of what this storm is doing. The other face is the cold air it is dragging behind it. The Weather Service Forecast Office in New York City issued a discussion yesterday afternoon with a sentence in it that operational forecasters in that region rarely write into a late May product. The sentence reads, and I am quoting directly here, "Temperatures will be within a few degrees of record lows Sunday morning at LaGuardia and JFK. Within a few degrees of record lows. Sunday morning, LaGuardia, JFK. 2 of the warmest urban island climate stations in the entire Northeast. The records the storm is going to come close to were set decades ago in years when North Atlantic blocking patterns did to the late spring jet stream what the current pattern is doing right now. To be within a few degrees of those records is to be living, for one night, inside the climatology of mid to late April, rather than the climatology of late May. What makes this cold air signal additionally rare is the synoptic setup producing it. Most cases of record near overnight cold in late May at the New York City airports happen during quiet, clear, post-frontal conditions with light winds. Radiational cooling under a high-pressure system. This storm is producing the cold under a strongly cyclonic pattern with sustained winds, which is the opposite atmospheric setup. The cold air is being advected in over a region that is simultaneously seeing high winds, which is a more efficient way to produce cold at the surface, but is climatologically less common because it requires a much stronger continental Arctic intrusion than radiational cooling does. The combination is what makes the overnight forecast for the New York City airports tonight stand out from the typical late May climatology, and the cold reaches further inland than the city. The New York City discussion noted that interior portions of southeast Connecticut may not get out of the 50s today, and that overnight lows tonight may dip into the upper 30s in spots well inland and across the Long Island Pine Barrens region. The Boston office and the office in Gray, Maine extended the signal further north. Patchy frost is in the forecast for sheltered high elevation valleys tonight in central Maine, New Hampshire, and northwestern Massachusetts. Wind chill values across interior New England this morning are forecast in the low 30s to mid and upper 20s. This is the part of the forecast that, if it verifies, will be remembered long after the wind dies down. The model guidance overnight produced a precipitation field whose freezing line was being pulled so far south by the cold air aloft that snow was on the table across northern New England. Higher elevations in western New Hampshire are forecast to receive 1 to 2 inches of measurable snow. Flurries are possible across Worcester, Portsmouth, and possibly reaching as far south as Boston during the early morning hours today. You need to understand what that snow signal actually means in context. Boston is a city whose climatological snow season ends in early April. Measurable May snow at Logan Airport has happened twice in the era of consistent record keeping. The most recent occasion was May 9th, 1977. The most recent measurable June snow in Boston was June 11th, 1942. The forecast does not call for accumulating snow in downtown Boston today. Any flurries that reach the city are going to melt almost immediately, because the surface temperatures will still be above freezing. The point is not that Boston is going to get a snow day in late May. The point is that the model guidance is producing flurries reaching the city at all, and producing measurable accumulation in higher elevations of western New Hampshire. The snow line is sitting on the latitude of southern New Hampshire on May 30th, 2026. That is the rare event. That is what is going to be remembered. The mechanism producing the snow is the same closed low producing the wind. The cold air aloft accompanying the low is unusually cold for the calendar window. As the storm's moisture condenses, the falling precipitation passes through freezing levels in the column. At higher elevations of western New Hampshire, places that are 2,000 feet up or more, the column is cold enough top to bottom that the precipitation falls as snow and reaches the ground as snow. At lower elevations across northern Massachusetts and southern New Hampshire, the precipitation starts as snow aloft and partially melts on the way down, producing flurries and a mixed precipitation type at the surface. And at the very southern edge of the snow signal, Worcester, Portsmouth, possibly Boston, the column is just barely cold enough for flurries to reach the ground at all. The snow signal is not a metaphor for the storm. The snow signal is the storm's precipitation phase, dictated directly by the temperature profile that the Omega block has handed it. The storm is hitting during the daytime hours of the Saturday of Memorial Day weekend, one of the busiest summer travel days of the year in this region. Cape Cod, Nantucket, and Martha's Vineyard are among the most visited summer destinations on the East Coast. The Massachusetts Department of Transportation operates the Sagamore and Bourne bridges that connect the Cape to the mainland. The Steamship Authority operates the ferry routes from Woods Hole to Vineyard Haven and Oak Bluffs, and from Hyannis to Nantucket. When sustained winds exceed 40 knots, the Steamship Authority typically makes the call to suspend ferry service. When sustained winds exceed 40 miles per hour, with gusts over 50, the Bridge Authority restricts high-profile vehicles. Power outages from downed trees on saturated soil have to be restored by utility crews working a holiday schedule, which means the restoration timeline is longer than it would be on a normal weekday. The Boston Forecast Office explicitly listed power outages as a primary impact. Emergency managers across coastal Massachusetts are preparing for mutual aid requests. If you are on the Cape today, or you are traveling to the Cape today, the operational guidance is clear. The wind impact window runs from 8 in the morning to 8 in the evening. If you have flexibility to delay travel until Sunday afternoon when the wind field collapses behind the storm, you will have a much better travel day than if you try to push through Saturday afternoon. The agricultural impact is worth flagging as well. Interior southern New England is in the climatological window for early season planting. Farmers across central Connecticut, central Massachusetts, the Connecticut River Valley, and southern New Hampshire have been setting out tender plants over the past 2 to 3 weeks under the assumption that the last frost date for the region has passed. The forecast for patchy frost tonight in sheltered high elevation valleys, with overnight lows reaching the upper 30s in spots well inland, puts those plantings at risk. Frost protection measures: covering tender plants overnight, running irrigation systems through the early morning hours to create a protective ice layer, deploying frost cloth, are operationally on the table for growers across interior southern New England tonight. The storm hitting New England today is not an isolated event. It is the eastern flank of a continental atmospheric configuration that has been holding across the country for approximately 10 days. The configuration has a name. Forecasters call it an Omega block, and the term has been written into the discussions of 5 separate National Weather Service offices over the past 48 hours. The Weather Prediction Center, the Chicago office, the Miami office, the Boston office, and the Philadelphia office. An Omega block is a configuration of the upper-level jet stream in which a strong ridge of high pressure becomes anchored in the middle of a continent, with closed lows of low pressure flanking it on both sides. The shape resembles the Greek letter omega. The pattern is named for the shape. The current Omega block has placed the central ridge over central Canada, with flanking closed lows over the western United States and over the northeastern United States. The eastern flanking low is the one producing the storm hitting Cape Cod today. The block has been producing simultaneous regional impacts across the country. The Storm Prediction Center has placed a slight risk for severe thunderstorms over western Nebraska, the Nebraska Panhandle, and southwestern South Dakota for today, with the primary threats being large hail and damaging winds. The official tornado probability is 2%, but the forecasters at the Storm Prediction Center have noted in their discussion that a more aggressive northwest moisture surge into the warm sector would support a higher tornado threat. The Weather Service office in Billings, Montana has issued flash flood watches for 3 burn scars in the Northern Rockies: the Elk Fire Scar, the Robertson Draw Fire Scar, and the East Side Burn area, where heavy rain today is going to fall on terrain that prior wildfires have stripped of its ability to absorb water. The Weather Service office in Grand Junction, Colorado has issued red flag warnings, covering 7 fire weather zones across southwest Colorado and eastern Utah. The Weather Service office in Morristown, Tennessee has issued a flood watch for southwest North Carolina and East Tennessee through this afternoon. Every one of those impacts is being produced by the same Omega block. The cyclone on the East Coast is the same wave. The plains, severe weather is the same wave. The burn scar flash floods are the same wave. The Mountain West fire weather is the same wave. The southeast flooding is the same wave. The configuration is the message. The storm is the messenger. The reason a single upper-level configuration is able to produce these simultaneous regional impacts is that the Omega block holds in place for long enough that each region underneath it has time to develop its operational signature. A typical mid-latitude weather pattern moves eastward across the country at speeds of 20 to 40 miles per hour, which means a given region experiences a particular regime for 1 to 3 days before the next regime arrives. The current Omega block has been holding for approximately 10 days. The block is not progressing eastward at the normal pace because the wave packets making it up are moving more slowly than the climatological mean. The technical term in the research literature for this kind of pattern is a low phase speed Rossby wave packet, and the slower the phase speed, the longer the regional regime persists. Recent literature in the atmospheric science community has documented the mechanisms that produce this kind of high amplitude blocking with simultaneous regional extremes. Research published in 2021 in Water Resources Research described slow-moving Rossby wave packets that lock regional weather into place for longer than the climatological mean. Research published in 2020 in Nature Climate Change described amplified planetary waves that produce simultaneous extreme weather events across multiple regions of the Northern Hemisphere. Research published in 2022 in Communications Earth and Environment demonstrated that the Arctic has been warming approximately 4 times faster than the global average since 1979, which weakens the temperature gradient that drives the climatological westerly jet. The literature does not predict that any specific weekend will produce a specific storm. The literature describes mechanism classes. The mechanism classes are what produce the kinds of configurations we are watching this weekend. The single event of May 30th is not in itself a fingerprint of any specific climate pathway. The fingerprint, if there is one, is in the repetition of these patterns across many years. This particular Omega block is one of several high-amplitude blocking events that have occurred during the late spring transition window in 2026 alone. The repetition is the part of the long-term pattern that researchers are watching. The Climate Prediction Center has issued a day 8 to 14 hazards outlook, covering the calendar window from approximately June 3rd to June 9th. The outlook signals that the cold side and wet side anomalies under the Omega block are going to extend through the first week of June. The Northeast is forecast to remain cooler than normal through that window. Periods of unsettled weather with shower chances are forecast to persist. The block holds. The exact timing of the block's breakdown is uncertain. The European model and the American model are now beginning to diverge on the mechanism by which it ends. The signal in the modeling is that the block ends sometime in the second week of June. When it does, the transition to a more conventional summer regime is expected to produce an active severe weather period across the country. There is also a low probability signal that the breakdown of the block could coincide with the first organized tropical development of the Atlantic hurricane season, which officially opens on June 1st. The forecast for the second week of June is going to depend on which model architecture is closer to right about the breakdown. But the broad outline is encoded into the wave packet structure that meteorologists are watching today. The first half of June stays under the block. The block breaks sometime in the second week. The pattern that follows the breakdown is active. If you are anywhere within range of the storm today, here is what to watch for. The wind impact window is 8 in the morning to 8 in the evening for Cape Cod and Nantucket. The wind advisory for the rest of eastern Massachusetts and Rhode Island runs through the same window. The marine storm warnings cover the coastal waters from Maine to Long Island and are active through this evening. Power outages are likely in the high wind warning zone. Travel disruption is likely across the Cape Cod and island ferry routes. The cold air component arrives behind the storm, with the overnight low at the New York City airports tonight expected to come within a few degrees of records. If you are at elevation in western New Hampshire, the snow signal is on the table. 1 to 2 inches is possible. If you are anywhere in interior New England, dress for wind chills in the low 30s to mid 20s this morning. We will be tracking the storm through the day. The Omega block holds through the first week of June. The breakdown comes in the second week. The repetition of high-amplitude blocking events in the late spring transition window is the long-term pattern that researchers are watching. The single event today is one chapter in a longer story that has been unfolding across the country all spring. That story continues.